In this lecture 4, I'm going to teach you the optics related topics. Probably this topics is a little bit away from the photochemistry. So if you are not interested in it, maybe you can skip this and for the next lecture. Okay. So I'm going to talk about some of the optics aspect, which is usually used for many photochemistry labs, and then some basic knowledge to use spectroscopic techniques. The first things I want to talk about is about lens, which is most fundamental optics, and in a photo related research. But however, in many cases, if you understand correctly about the general aspect of the lens, you can build up many sort of the optical measurement. However, many of the students actually don't understand very well how to use the lens. So I want to review it again. So first, this is the general optics, which is used for the expansion and reduction of optics. So here's a formula for the lens. If you have an object and lens with a focal length of f, and then object, real image, you can find is the distance from the lens to image is defined as b. This formula, you can use this formula. 1 over a plus 1 over b equal inverse of f. So here's a general drawing, how to obtain the image, real image. If you put the object outside of the focal length, and you can obtain the image on the other side of the lens, which is called real image. Okay, so how to draw this is first you have to make a parallel line to this basic line, and then this is connected to the other side of the focal point, and then extend it. And another line is given from the object point to the center of the lens, and then connected. So when these two lines are connected, you can find a real image. So this is quite general. And on the other hand, if we put the object inside the focal length here, you cannot make an image on the other side. It's obvious if you draw, because so one of the line is first make a parallel, and then this one is connected with other end of the focal position, and the other line is this one is connected to the center. So if you look for the other side, these two lines keep distance, getting far away. But if you going back side, these two lines can overlap here. So in this case, the image is the back side of the object, which is called a virtual image. So it's a very fundamental aspect of the lens. And the key point the key point for these two types of the usage of lens is the image is expanded as the object approaches the focus position. So please, for yourself, please draw how it works, okay? So please stop the video and then please draw as the object approaches to the focus position. How can you make the image big? Okay, then here. So if the object is close to the focus position, the one of the light. So this one, this line, and this line. So at the object position, these two lines are parallel. So a little bit away from the lens gives a very big image because these two lines are quite close to the parallel line. But at very far away position, and you can obtain the very big image. Similarly, even in a virtual image case, if your object is near the focus position, these two lines are getting parallel, but a little bit inside, these two can overlap each other. That makes a very big virtual image far away from the object, right? So always, in many cases, you have to adjust the focus to see, but what you are actually seeing is the object is not always at the focus position, not the focal position. It's just very good. If you expand the object, you put our object close to the focal position and then make the image bigger. So if you understand these two things, probably you have experienced using the microscope, which is still very useful in many researches. Now, and this microscope combined the image expansion, what I talked about real image and a virtual image. So let's think about this. So here the small object and this object. So always the object, near the object, you have an objective lens, right? Objective lens. By using this objective lens, this image is expanded by using the real image expansion. Very short focus position. The object is getting big, but you cannot make the infinitely make it big because of the space limitation. And when you observe this object, you use the virtual image actually. So using the eyepiece lens, this image is now the inside of the focus position. That's why you could see the virtual image backside of the object like this. So finally, your object is now big virtual image like this. And if you look this object from this side with your eye, it becomes very big like this. So this is the principle of the microscope. So always you are combining these two imaging technique. So virtual and real.